Honors Geometry, Section 12.2, Circle Terminology. Definition of a circle. A set of all points in a plane that are a given distance from a given point in the plane. So for example, circle K, you name a circle by its center. This here is circle C. In circle K, K is the center. That's the point in the middle of the circle on which all the points are equal distant. The red part is the actual circle. Chord, a segment that has endpoints on the circle. Segment AB is a chord. Segment CD is a chord. They are segments whose endpoints are on the circle. Add this segment AB, segment AD. Diameter, a chord that contains the center of the circle. In these two pictures, there's only one of those, and that is diameter AB. Radius. There are three of these in the two pictures. A segment with one endpoint at the center of the circle and the other endpoint on the circle. This is a radius, this is a radius, and this is a radius. So segment AK, segment KB, and segment CF. I'm going to write one of those in the picture so it's easy to see. Radius. Arc, an unbroken part of the circle. There are three varieties of arcs. There is minor arcs, major arcs, and semicircles. If you go all the way around the circle, that's 180 degrees. If you go halfway around, I'm sorry, I misspoke. If you go all the way around, it's 360 degrees. If you go halfway around, it's 180. Minor arc, an arc that measures less than 180 degrees. So in this picture, whoops, arc AB is a minor arc. Symbol for arc is drawing a little arc over top of your endpoints of your arc. Minor arcs always use two letters. Major arc is an arc that measures more than 180. Major arcs always use three letters. If I say arc BC, and we didn't use three letters, you wouldn't know if I meant this one or this one. Since a major arc uses three letters, pardon me, I belched. Arc BAC is a major arc. If I wanted to refer to the short distance from B to C, I would use two letters. It would be arc BC. Semicircle, an arc that measures exactly 180, that's half the circle. Arc ADC is a semicircle. Pardon me. A circle separates a plane into three parts. You got the interior, which is the part that I'm shading here. You got the exterior, which is the part that I'm shading here. And then you have the circle itself, which is this red thing that you already see here. You got the inside, you got the outside, you got the actual circle. More terms. Tangent, a line that intersects a circle in exactly one point. This line right here is a tangent line. Point of tangency, the point at which a tangent line intersects a circle. Point T is a point of tangency. Tangent segment is a segment that intersects a circle once, and if you were to extend it, it would still only intersect it once. Segment VU is a tangent segment. Secant, a line that intersects a circle in 2 points, that would be line CB, is a secant line. Area of a circle and circumference of a circle. To find the area of a circle, you take the radius and square it, then you multiply it by pi. So area is pi r squared. In this case, the radius is 4. Let's say it's 4 feet. 4 squared is 16. Area is measured in squares, so this is 16 pi square feet. It literally means, when you're finding area, how many of these squares that are 1 by 1 can you fit inside of this? Circumference is the distance around. It's how long the distance, not how long, it's what kind of, let's say that we're using feet. Sorry, I'm stumbling over my own words. Circumference in this case would mean if you start here, how many feet would you have to walk around the entire perimeter of this shape? Circumference is 2 times pi times r, or 2 times r times pi, or diameter times pi. We usually speak in terms of radius. If the radius is 4, that would make this 8 pi. Talking about linear distance, so that's just feet, as opposed to area, which would be square feet. Give an example of each using the picture. There's multiple correct answers. Supposed to name a radius. Here's a radius. Let me change my highlighter here a little bit. Here's a radius, that's 1. Here's a radius, that's 2. Here's a radius, that's 3. Name any of those. I'm going to name segment AC as a radius. I'm just going to skip around on these questions here. Diameter is a chord that goes through the center. Picture only shows one of those, segment DE. A chord is the segment whose endpoints are on the circle. There's one chord. There's another chord. There's another chord. You can name any of those 3. I'm going to name chord DC. Secant line is a line that intersects the circle in 2 locations, such as line DF. A minor arc. That's an arc that's less than half the circle. Arc DC is a minor arc. A tangent line is a line that if you were to extend it would only intersect the circle 1 time. Line BG is a tangent line. You can use any combination of points B, C, and G to name that line. Center of the circle is point A. A major arc is more than halfway around the circle, and you got choices for this. I'm going to choose arc DCF. An exterior point, you could choose B or G. Semicircle is an arc that goes halfway around the circle. So you could choose that semicircle, or you could choose this one. I'll choose the bottom one. Arc DFE is a semicircle. Circles A and D have a radius of 4 centimeters and 1 centimeters respectively. Respectively means in the same order. So let's say this is 4. If this 4, every radius is 4. And I'm going to mark every radius in that as 4. Don't let your mind assume it's 4. Write it in there. Second one, the radius is 1. I'm going to write 1 in every location that I can. Find the missing values. Before we do that, let's check out this right triangle that we see in here. This right triangle has a hypotenuse of 5 and a leg of 4. That means this other leg must be 3 because this is a Pythagorean triple. A 3, 4, 5 right triangle. If you don't recognize it's Pythagorean triple, you can use Pythagorean theorem and figure that out. If that leg is 3, that means CG has to be 3 minus 1, which is 2. Let's see if we can answer these questions. What's the length of BF? Well, BF is a 4 and a 4, which is an 8. It's 2 radii in the same circle. Segment CD's length, well, we already had that figured out. It's 3 because it's Pythagorean triple. Segment AD, well, it looks like that's a 4 and a 1, which is a 5. Segment CG, we already figured out was 2 because 3 minus 1 is 2. What's the perimeter of triangle ACB? Well, that's 12 because we have a 3 plus a 4 plus a 5, which is 12. Draw the following relationships. Secant line AB, so it touches the circle twice, intersects circle M, let's label this, that has to be M in the center, at points A and B. So draw a secant line. It only mentions A and B for this line, and it says those are the points that touches the circle. This problem only mentions 3 points, and we have all 3 points on here. Secant line MN intersects line TM on circle R. So the only thing that I know for sure right now is this is circle R. I know I have a secant line, MN, I'll draw that first. It says secant line MN intersects tangent line TM. Now, those share the same point M. I'm going to assume that that's the common point here. So if I draw this tangent line TM, and the secant line MN, N can be any place on this line. It doesn't say that N is the point that touches the circle, so you can put it any place you want. I'm just going to conveniently put it here on the point of intersection. This is one version of the circle, of the picture. You must have a tangent line. You must have a secant line. They must intersect at a shared point. It's the only shared point they could have is M. And you have to have circle R. Last one. Diameter segment AB. Diameter is a chord that goes through the center. It's named AB, so one endpoint's A and one is B. Intersects tangent line GB. Now B is on the circle, and the tangent line hits the circle once. So that must mean this tangent line hits so that B is the point of tangency. It says on circle M, so M's the center. Let's make sure we got this right. Circle M, got that. Diameter AB, we got that. Tangent line GB, we got that. That concludes the notes. That finishes section 12.2. Please do the homework. Thank you.